In this video, I'm going to show you how to remove elements from a max heap. So here we have the existing heap. We're going to remove an element. The only element I can remove on a max heap is the biggest. The only element I can remove on a min heap is the smallest. In either case, it is the root. So we're going to remove the root. In my case, that is 74. I'm going to just write this down to keep track how many elements I have already removed. I have 74. I'm going to remove it, and now I have a hole here. Now, one of the important properties of a heap is that it is complete. Each level needs to be complete, including the root. So to ensure the heap remains complete, we bring up the last element. That is a crucial step. So my last element is 28, last row, last element going from left to right, 28. I'm going to bring up 28. Now, at this point, my tree is complete again. However, in a max heap, the root always has to be greater or equal than the children. That is no longer the case. So we bring up the last element, but then we have to sink it low enough that for each of the subtrees, the root is greater or equal than the children. So in this case, I check 28 is not greater than 50 and 38. Now, in which direction should I sink? I should sink in the direction of the larger child because it's a max heap. So if I would sink on the right hand side, 38 would not be greater or equal to 50. So I need to sink to the left side to my larger child, and 28 sinks, 50 goes up. Let's make that happen. 28 sinks, 50 goes up. So here, 28 and 50. Now, when I look at that, the heap property works nicely. 50 is greater or equal to 28 and 38. However, am I done sinking? So I have to check, is 28 greater or equal than 42 and 24? That is not the case. So we have to continue sinking, in this case, again to the left side, because 42 is greater than 28. So 28 is going to sink, 42 comes up. At this point, I can check 42 is greater or equal than both of the children. That is great, but am I done sinking? So that is an important step. We always have to check whether further sinking is needed. And I look at the two children and I realize 28 is not greater or equal than both 40 and 12. So 28 needs to continue to sink, and 40 comes up. At this point, I can look at the children. There are no children. This is a leaf. So we are done. 28 is now at the bottom. 50 is the new root. It is a heap again. The heap requirements are fulfilled. At this point, I remove the second element. It says you should remove 4 of them. This is great. We're going to remove 50. I'm going to make myself a note just to make sure I keep track how many elements I'm removing here. Remove 50. Next step is I find my last element and bring up the last element to the root position. That is 24. So 24 is my new root. And at this point, my tree is complete, but 24 is not necessarily greater or equal than both children. And if I look, I find it's not the case. So 24 needs to sink, and it needs to sink on the left side. So 24 is going to move to my left side, and 42 comes up. 24 sinks, and 42 moves up. And I can see 42 is a good root for the tree because it's greater or equal to both of the children. Are we done sinking yet? No, we're not. So 24 keep sinking, and 40 goes up. So 24 keeps sinking and 40 goes up. Now notice we have 24 twice. That's perfectly okay. Heaps do allow duplicates. But am I done sinking? So I'm looking here and I can see 24 is not greater than 28. So we still have to do more sinking. 24 sinks and 28 comes up. So here is 24 and 28 comes up. At this point, 2 elements have been removed, the heap properties are restored, and we have a complete heap. Each root of each subtree is greater or equal than the children. So let's remove the third element because we need to do 4 elements total. This is 42. I'm going to write this down to keep track of the number of elements. I remove the root. As a matter of fact, pause the video. Try it for yourself. When you're done, press continue. So at this point, I'm going to show you what I do. I remove my root, 42. I bring up the last element from the last row. This is 22. So 22 is right here up in the root position, but 22 is not greater or equal than the children, so it has to sync. I check which is the bigger one. It's 40, so 22 is going to sync, 40 is coming up. I'm not done syncing. I double check. We're not done syncing. 28 is bigger than 22, so 22 is going to sync and 28 comes up. And again, I'm going to check, am I done syncing? I'm not done syncing yet because 24 is bigger than 22, so 22 keeps syncing and 24 comes up. And at this point, 3 elements have been removed. The heap properties have been restored. It is a complete tree, and every subtree has a root that is greater or equal than the children. At this point, we remove the 4th element. Pause the video, try it yourself. When you're done, press continue. So at this point, I'm going to remove the last element. We always remove the root. This is 40, and I am going to remove 40. I bring up my last element, that is 16. So 16 comes up, and we have the requirement fulfilled that the tree is now complete, but 16 is not greater or equal to the children. And when I check, I can see this time 38 is greater than 28. So we have to sync to the right side. 16 is syncing and 38 comes up. At this point, I'm checking, are we done syncing? Here is 16, 34 and 18 are both bigger than 16. I have to take the bigger one between the children. In this case, this is 34. So 16 continues syncing and 34 comes up. And at this point, we removed 4 elements. We restored the heap property that each of the roots of each subtree is greater or equal than the children. And we have ensured that the tree is complete. And then when we enter the solution in Canvas, we start with the underscore, and then we list all the elements level by level, separated by a space. I'm going to pause the video. And here we are.